A particle is moving along a curve and its position is given by s of t units. The velocity, also known as the rate of change of the particle, is given by the equation v of t equals 0. Blah, 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 blah. For 0 is, or t is between 0 and 14, but not including. I probably could have included those. Doesn't make a difference. Which of the following is true about the position of the particle? This is a problem that I made and I was inspired by calculus. They love to give you the particle velocity type questions. And this is what the question is asking. It's giving you the velocity function, right? Now, the velocity of a particle is also its rate of change, also its slope. So we have to understand that if the velocity, okay, also known as the rate of change, also known as the slope, if the slope is negative, okay, if the slope is negative, that means its position has a negative slope and its position is going down. Now, what that means with a particle is a particle can like go up, down, what we don't know. But if the velocity or the slope is negative, the position means it follows a negative slope, it's going down. If the velocity, also known as the slope, is positive, okay, that means its position is following a positive slope, so it's going up. So there's two things that we're looking at here, okay? One thing is this picture that I kind of drew here. So thing number one is if you have a negative velocity, a negative v, and then all of a sudden it changes to a positive velocity, positive v, you have yourselves a minimum, okay? You have yourself like, okay, well, here it is. If the particle's moving along at a position, that's what happens when your velocity or slope changes from negative to positive. Similarly, if our velocity goes from positive and then all of a sudden changes to negative, we have ourselves a maximum, local maximum. So maybe something like this. Okay, so what we have to do is we need to graph this. We need to graph the velocity function and find out where it's positive and find out where it's negative and find out where that change is. Okay, because if it's positive and then becomes negative, then it looks something like this. Positive slope, negative slope, we have a maximum. If it's a negative slope that changes to a positive slope, we have a minimum, and we could probably answer these questions here because these answers are talking about zeros and local minimums and maximums and stuff like that. So let's run to our calculator and see what happens when we graph that guy right there. All right, so we are looking at graphing that velocity function, which was pretty unpleasant, but we'll be all right. 0.765, it says t, but t is x, minus 2.654. 2.654. Now, before I even graph this, we care about magic happening between 0 and 14. So let's change our window from 0 to 14, like so. Let's hit graph. Now, remember what I said on this slide. When you have a negative slope, that means your actual function is going down. When we have a positive slope, that means our actual function is going up. So here's a negative slope, here is a positive slope, and we should probably find out where that changes. So second calc 0 will tell us where our slope, or this velocity function, which is the slope, changes from negative to positive. So if we put the left bound to the left of it, put the right bound to the right of it, and hit enter for guess, we have 3.469 or 3.469 is where our slope goes from negative to positive. So let's go back and try to diagnose what that means. All right, so as you can see from the multiple choice options, 3.469, the number that we saw in the calculator, is going to help us out. What we saw in the velocity graph that we drew in the graphing calculator or saw in the graphing calculator is the slope went from negative to positive at that 3.469. Okay, so that 3.469 is telling us that we have something that looks like this, so I can get rid of you because you're no longer a viable option. We have a position where this particle is like traveling down some type of roller coaster and hits the very bottom at time 3.469 and then goes back up again. So this is a local minimum at 3.469. So the particle's position is 0 at 3.469. No, that's not true. The particle's position is at a local maximum at 3.469. Nope. The particle's position is at a local minimum at 3.469 because the velocity, also known as the rate of change, changes from negative to positive at that value. That's my guy. The particle is always increasing because the velocity is always increasing. No. The velocity always increasing has nothing to do with where your position is. It just means you're speeding up. And if you're going down a hill, you're probably going to speed up at some point. So yeah, there you have it. Very strange problem, very different problem. But this problem mirrors a similar problem on the second or AP classroom practice test, whatever it's called. So yeah, I'm not just pulling this out of thin air. It's something that you could possibly see. So hope this helps.